All right. So where we left off on Monday, I had drawn out this Turing machine here, but the thing is, it's only the beginning of Turing machine in the sense that the Turing machine needs to be able to be represented non-graphically. So you need something like, so you've got state, symbol, action, or tape action, and state change. So everything needs to be listed in this format. For example, like, I don't know, Q0 and the tape symbol will be like A, and the tape action will be like write B, and then the state change will be Q, B, C, something like that. So we have everything we need down here in order to make that. This is the hard part. Like everything that's difficult is already done. I just need to figure out what these lines are going to look like. The reason we already have that is because, so look at the one thing we may not have is we may not have all the appropriate states. So we start at Q0. So what's the first thing we do on Q0? Well, we do a read, and I guess we call that overwrite A. So if the cell is A, then write X and begin find first B. Okay, so the translation for that here is going to be state Q0, tape symbol A, write X, state change to a state indicating that we're looking for B. Now, I believe AB wasn't quite that. I believe AB, let's see, where...
Okay, so I have a question though.
What's up?
Since you said like the Turing machines won't know everything, would they know that the first letter would be an A, or just assuming that it knows it's an A?
Um, so ask your question again.
Did we take into account what if would the Turing machine or whatever we're dealing with right now, would the language know that the first letter is going to be an A for us to overwrite A?
Well, that's the thing. If it
Or
doesn't have an appropriate line, then it can't do anything, and it doesn't halt. It only
okay.
halts when we tell it to, and halt means accept.
Do we have a
So
palindrome for this thing or no?
we did
Just
do that. I believe we did that on Friday.
oh, yeah, we did that.
So
So
I'm going to
we
make
don't do
some
the
more
comp.
states here,
Okay.
and we're going to make them. So we have the initial state. We have find first B is what this is going to be.
Yeah.
We've got found the first B. We're going to have find the first C. I'm going to make one here. I think this one's too tall. We've got found the first C. We've got find end, and we may need one to go back to the beginning, but I think this is going to be fine. So I'm going to call this one this is going to be find our first B. So I'm going to call this, I believe
AB.
AB is a better name for it, and I'm just going to call this one B. This means we found B.
So you're saying we found B after A? Is that what a QAB stands for? Basically?
Yes. And
Okay.
I'm going to make another one actually. And I'm going to call that one QA because I think we're going to need to find the first A, but maybe depending on how we wrote. Yeah, because we have go to start, we may not need it. We'll see. And I'll call this one Q BC. This is going to be find the first C, and then this one is going to be I've found the first C. So these labels I have here, these were useful for when we were constructing the whole thing, but we don't need them right now. So our Turing machine looks like this. What are we going to possibly do in Q0? Well, there's going to be the operation of I've got an A there, so I'm going to write an X, and I'm going to find the first B. That's what I have here. I'm doing the overwrite A thing. I also know that if I'm in Q0, I think it's always going to do that. Of course, you got to capitalize everything. And if I see a blank, the end of the string, then my action is going to be this. I don't have to do anything. And really, the state change here is just halt. So you can have a state labeled halt, but really the action is just halt. Because halt means accept.
Right.
Now, since we've done the whole work of doing everything we need to, what other things could we end up in Q0 with? Well, we've handled the reasons we're going to be in Q0 is if we're starting off, we found the end of what we're looking for, or we found the end we're coming back. So if we found the end, move right, read the cell. If we read a blank, go to the start. Okay, so go to the start, move left, beginning of the tape, begin find first A. So this is something we're probably going to need a Q0 line for. And this one is probably something we're going to need a line for, but I'm pretty sure we already wrote it. So we'll see. The question I'm going to have to ask once I write these lines here is, did I get this one? Did I get these two correct? And did I get these two correct? So everything I have written down here in English, I need to have written up here as a line for a Turing machine. So let's look at go to start. I don't think that's going to be a Q0. I think that's going to be a Q end. Let's look at, why do you always capitalize? Let's look at find first A. So move right. So if the tape symbol is X, we're going to move right. Now these actually have labels in the paper. I think it's something like this. And so move right would just be MR, but I will leave it as is for now. So move right. And state change, we're not changing states. Stay in Q0. All right. All right, so did we handle find first A? If it's an A, begin overwrite A. We already have that line encapsulated right here. If it's empty, begin halt. And if it's anything else, reject. We don't have to write that line. So as far as Q0 goes, it kind of looks like we've got what we need. So let's look at QAB. Do you have any questions before I move on?
No.
Okay, so let's look at QAB. What is this state? This needs to read QAB. This is generally the state we're going to be in while we're looking for the first B after we found an A. So there's a couple of things we can run into. The first one is if we run into what we're looking for, which is a B, we're going to do some stuff, which is going to be, we're probably going to write an X, and this is going to be the overwrite B. And we're going to move into find the first C subroutine, and that's what we have the QBC state for. Other things we can run into in QAB, which is, as far as I can tell, the only things we're going to be doing here are we're either looking for a B or we found one. It's in the middle, so we don't have to really handle the end or the beginning part. So if we're looking for a B and we found an X, Um, we don't do anything. We just move right. And as I'm looking at this, I see something. You not only need to write X, you need to also move right. So I'm gonna just use MR because we're running out of room here. Um, MR. So write X, MR. This is going to be MR. Okay. Okay, so if we see an X, we don't need to write
I have a
anything.
question.
What's up?
So remember, so I know we had to do the go to the start thing to get another A and then get another B. Couldn't we have just done it one in one full swoop? Let's say we got A, we write the X there, we overwrite A, looking for a B, but we still got an A. Could we not just exit out there as well and then keep on doing that?
Sorry, say that again.
No.
I just didn't understand. Could you say it again?
Okay, so I know for the first iteration, we found an A, we overwrote the A and we put an X,
Yeah.
and then we wanted to find a B, right?
Yep.
But in the process of finding the B, since we found A's before B's, could we not just mark off the A first, like all the A's, and then when we found the B, just mark that off and then continue until the same thing we wanted to do for finding C's?
You want to mark off more than one A at a time?
Yeah.
You can do that. That was the way in the book. But in order to do that, how are you going to keep track of how many A's you marked off?
I mean, since we already know we mark off one A, we just keep marking off until we can't see. I mean, wouldn't it be the same way we did it for the first iteration though? Just one time.
Well, what I'm asking is, how does the machine know I've marked off one A versus marking off two A's versus marking off three A's? Because in this method, we're only marking off one A symbol, one B symbol at a time.
Okay, so with us marking off one A and B symbol, we're moving states that helps keep track of how many.
You cut out. You're really mumbled. I can't really hear what you're saying.
You can hear me better now.
Yeah.
I was saying that since we doing it one by one, let's say we mark off one A, we're in the QA state, then we move to the QB and we move to QC. That's how we track each A and B and C, right?
Yep.
Okay.
Well, that's not how we keep track of each Q, A, B, and C. That's how we keep track of what are we in the process of doing. Now, we may actually not need all these states. I'll see here in a second once I write them all out.
Okay. So how do we keep track of each A, B, and C that
What
we
you would
marked off?
do is you mark off one A, you go to the end of the tape. You find the first empty piece, you write some symbol. In the book, it's D. And then you go
Okay.
back to the first A and you mark off another one and you go write another D at the end. You do that until you run out of A's. Now, you're going to go to your B, you're going to mark it off and see if there's a D over here on the right. If there is, okay, keep marking off B's. If you don't have enough B's and there's a D left over, it's error. If you have too many B's and there's not enough D's, it's an error. Same thing with the C's. So you have to use another symbol here on the tape in order to do what you're trying to do.
Is it like the push down automaton whenever you have like the
You're mumbled again.
sorry. Is it like the push down automata when you see an A, push it in A, if you see another A in another state, you pop an A, that kind of thing?
Sort of, but
Not the
more
same
what
thing,
you
but
need to
similar idea.
more what you need to think of is, so this is the question I was trying to get people to ask, is what if we had more than one head? Well, the
The
thing
two
is, you
tapes? Okay.
you don't really get any more power. You can't do anything new, but you can do things easier. So imagine, when you go and you look at your computer, it's going to go look at RAM. Every head you have just means how many times can I be looking up RAM. If imagine you didn't have an infinite number of heads, but you had functionally an infinite number of heads, meaning if I needed 10, I had 10. If I needed 50,000, I have 50,000. Whatever number I need, I've got it. That just means your computer is perfectly parallelized.
Okay.
you can't do anything new with parallel computing. You can just do it faster and better and easier. So if I had two heads here, I could keep one head to keep track of the number of D's I have to show that, hey, I know I have 4 A's. And so I'm going to write down this D symbol, and it's just going to keep over there. And I'm going to keep, and my states are going to be whatever tape A is reading, whatever tape B is reading. You could do it that way. But since we only have one head here, you've got to move to the end of the tape where we've written down the D symbol. And every time you erase something, you got to move and check. And then every time you're like, okay, it's good, move back. And then do that over and over and over. You're using the tape as memory.
So do we have to keep only one symbol for, or can we do like D for A's or
You could
X
you could
for
replace it with
B's?
anything you want. You could use D for, all right, every time I erase an A, I'm going to write a D. Every time I erase a B, I'm going to replace the D symbol with an E symbol to indicate that this is how many A's I erased and how many B's I erased. And then you can go to your C's, and if there's not enough E symbols there, then you know that's going to be a problem.
Okay, I think I follow.
But yeah, you use the tape is your memory.
Okay.
So let's see. If I'm A, B, and I find a B, yeah, I don't think I need all of these states. So let's just try it like this. Now this needs to stay that way. This will stay there. And essentially this turns into QA is what it is. All right, so if I'm in QB, meaning I'm looking for a B, and I found it, I'm going to write an X, I'm going to move right, and I'm going to go into QC. If I'm in QB, meaning I'm looking for a B, and I find an X, I haven't found the B yet, so I'm going to move right, and I'm going to stay where I need to. If I'm in QC, meaning I'm looking for a C, and I found the C, then what I need to do is I need to start this whole end of the tape thing. So what I'm going to do is I'm going to write my X. I'm going to move right, and I'm going to go to state Q end. Now, if I'm in QC and I find an X, I'm just going to move right because I haven't found the C yet, and I'm going to stay in QC. Okay, so if I'm in Q end, and I see the end of the tape, which is going to be this symbol. That means I found the end, and I need to start the go to start, go to the beginning. So what I'm going to do is I'm going to move left, and I'm going to go into the state change of, let's just call it Q beginning, even though we don't have one of those right now. I'll just change this one to be Q beginning because I don't think we need that one. If I'm in Q end, as in I need to find the end of the tape, and I find what else could I find? All right. So I think I missed one here. So let's say I'm in QA, meaning I need to find the first A. My possible things are I found my A, so I write an X. Let's erase these X's so this is more clear. Oops. And if it erases the symbol, that's fine. It does. I think this was an error. I think this was an incorrect thing anyway. So again, excuse my drawing here. So how many do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9. All right. 3. A, B, 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 C, C, C. All right. So I start out in QA. I'm looking for an A. I find an A. I write an X, and I move to the right. But now I'm in QB. So here's the thing I believe I've missed. I'm in QB, and I have something for if I find a B or if I find an X. The thing is, I think this needs to be, instead of an X I'm looking at, it needs to be an A, because right now I'm looking at an A, and that's totally fine. I'm just not looking for an A. I'm looking for a B. So I think I need to change this from, if I'm in QB and I'm looking at an A, I'm just going to move on. And if I'm in QC and I'm looking at a B, just move on. If I'm in QN and I'm looking at a C, I'm just going to move on. Do you follow why I made that change?
Why did you make that change?
Okay, so before I had it to where so I've just written an X here, meaning I found the first A. Now what I need to do is I need to find the first B. So in order to find the first B, I move into my QB state and I move right. So I move right. So now I'm in the QB state. Now before I had a rule for if I'm in QB and I see a B, I do something. And if I'm in QB and I see an X, I do something. But I didn't have a rule for if I'm in QB and I see an A, what do I do? Now I'm in a QB state. I'm looking for my first B. I see an A. What should I do?
Yeah, just reject.
What was that?
Did you reject that A?
No, I don't reject it. This is a perfectly fine string.
Or should you just move on then?
I do just move on. It's like I haven't found the B yet. I haven't ran into anything incorrect. I just haven't found the B, so I just move on. There's another A, so I need to move on. There's the B. I need to change my state somehow. So that's the reason I changed that. Now this line here, I'm not sure what to do with yet.
Okay.
I have the same thing on the C line, meaning I've gone from, I don't know why the arrow's not moving all the way to.
Okay, so just to make sure, the QB state is saying that you're looking for a B. You haven't found it. You're just looking.
That's correct.
Okay.
The QA or the QB state is I'm looking for a B. The QC state is I'm looking for a C. The QN state is I'm looking for the end. The Q beginning state is I'm looking for the beginning. And the QA state is I'm looking for the A.
Okay.
Now I wish, I'm just going to have to draw a new arrow because this thing doesn't want to behave. All right, so let's look at this from the B perspective. Now I'm in the QB state. I'm like right here. I move to the right because that's what the rule says. I just move on. Now I found a B. What should I do here? I found a B. Should I leave it? Should I move on? Should I override it? What should I do?
Wait, sorry. It's
It's fine. So let's say I start from the beginning. I find the first A. It's definitely not empty. So I'm going to mark an X. I'm going to move on until I find a B. I found the first B. I'm in my QB state. So I'm essentially looking for one B. I found a B. What should I do with it?
Mark it an X.
So I mark it out. And then what?
And then you move on to find a C.
All right, I move on, and I'm now in the state of mind of I'm looking for a C. So that indicates we're in the QC state.
Yeah.
So I'm going to mark this one out. And it won't let me grab it. There we go. All right, so now I'm looking for a C. I'm in the state of QC, meaning look for a C. So I haven't found one yet, so what should I do?
Just move on until you find a C.
All right, same thing. I haven't found it yet, move on. Hey, there's one. What should I do? I'm going to mark an X, and now what am I looking for?
The empty symbol.
Yeah, I'm looking for the end of the string. So I'm going to mark this out, and I'm going to change my state because now my state is I'm looking for the end. So I'm going to move on here. I'm going to mark this out, and I'm going to move right until I find the end. So I've changed that. The thing I just pointed out is we were in the find C state. I found one. I'm going to mark it out, move right, and now I'm no longer in find C mode. I'm in find end mode.
Okay.
All right, so those look fine. Let's think about the end. So I found the end. If I'm in the find end mode, I can find a C and I don't do anything. I just move right. If I do find the end, what should I do now? Well, I'm going to move
Wait.
left now and look for the beginning.
Okay. So
So I'm going to
don't you
keep
mark
moving
off?
left until I find the beginning. I'm not actually going to mark off anything. I'm just going to move left.
Okay.
Now, we were going under the assumption that there's some beginning symbol, and that's fine. There's not actually one, but let's just assume there is, and we'll call it, I don't know, $sign. We'd used that before. It's fine.
Yeah.
I'll just change the string real quick to indicate that that's where we start. All right. So that means that this isn't really, oops, this is not really the initial
Start
state.
state. Initial state.
Yeah. The initial state is kind of this one, and it looks like we
So
might
would
be able to use the beginning. So we'll see if we can use that.
okay.
So if I'm in the beginning state and I see a $sign, that means I found the beginning. I don't want to overwrite it, but I do want to move right. And I want to
Missing
start
X.
my look for an A routine. That's what I want to do.
Oh, that makes sense.
If I'm in my queue beginning mindset, I don't know why I keep doing that, and I see anything other, I should have gone with like, we're just going to use any right now. If I see anything
Use
other
hashtag.
than the $sign, I'm just going to keep moving left. And I'm going to stay in my original, and I'm going to stay in that state because I haven't found the beginning yet. Is there anything more I need to do? Okay, so while I'm looking for the beginning, now I start here and I'm in my look for beginning mode. Is there anything I need to do other than move left, or I found the beginning and move right one?
I think just keep moving left since you're at the end and you song from the beginning, and then you move right after from the beginning, and then record. You already have an X there.
Yep. So
A.
that's actually it. We don't need to worry about the X because that's in the QA. That's already handled right here.
Okay, that's true. Yes. So they would just look for another
So
aid, no
I believe
matter
that's
what.
it. Q beginning only has two things, and if I'm not mistaken, this is the initial state.
So do we have a repeat state or something?
Nope, you don't need one. Because these states only refer to what is the task I'm doing.
Okay, so
So I could actually call this, and I will up here. This is actually what I'm doing. This is find A, find B. I might not be able to get these to look pretty. Find C. This one I don't think we need. And find end.
Okay, that makes more sense now.
Yeah, the states are different than what we were having before with pushdown automata and stuff because really this diagram I'm drawing, this is only here for you to visualize and help. That's it. That's all it's for.
So do we need the halt and to the halt state still?
Nope. These aren't needed.
Okay.
I was just making them because some people want a halt state and some people want a reject state. I personally don't. If someone were to make them, it's totally fine. Essentially, if you wanted both of those, so this line here says when to halt. And then for every state I have, if I see anything other than what I am seeing, just no action and go to the reject state if you wanted to do it that way, which is totally fine.
But shouldn't we still have the whole state? Because when we mark off all the A's and all the B's and C's, and we're at the end, it's like, okay, just stop. Or we just automatically just stop looking after you realize that it marks off all the A's.
Well, you don't, and here's why. Because there is a special action called halt. And what this action means says, I'm done. It is accepted.
Okay.
So that's the reason I don't like having a halt state, because there needs to be to halt. For a Turing machine to halt is a verb. And this is how the Church Turing thesis is written, to say a Turing machine will halt if a algorithm is computable. So that's why I like it this way. If you want to make a state for halt, that is totally fine. I don't care.
Would it matter for any number of A's, B's, and C's? What if we had like three A's, two B's, and one C?
Right. So we did that earlier in class, and I don't mind doing it again, but I want to go through and make sure I've got this right. So we actually begin here. This is the, well, that was weird. The initial state is there. If I see $, that means I'm at the start of the string. Move right and go to find an A state. All right. So if I'm in find A state, if I see end of the string, that means the string is empty, and I halt. I'm done. Otherwise, that's actually not only the thing it means. It means I could not find any symbol other than X between the beginning of the tape and the end of the tape. That's what this means. This line here, I'll say that again because it's important. This line here says, I've reached the beginning of the string. I've begun my routine of looking for an A. I couldn't find an A anywhere in the string. The only things I saw were marked out symbols or nothing, meaning either the string was empty to begin with, which is acceptable, or I marked out an equal number of A's, B's, and C's, which is also acceptable. So I found the end of the string with no A's, no B's, no C's in the middle. So that's what I'm looking for, so I halt. The other options are, I'm looking for an A, I found an A. Okay, cool. Mark it out and start looking for a B. The other option is, I am looking for an A and I've seen a mark out. That's fine. Just keep moving right and keep looking for an A. B has the same thing. It just doesn't have the halt because I only need that once. If I see an A, that means I've already marked out my A and I haven't found my first B yet, so keep going. If I see a B, that means I've found the first B, mark it out, and look for C's. If I'm in the C's and I see a B, that means I haven't found my C yet, but keep going. If I do find a C, that means I've found the first one, mark it out, and look for the end. You're never going to find an X on the B segment while I'm looking for a C, because you only ever do this on the let me think about that for a moment. Yeah, the only time you're going to find an X, I think, is here. So if I'm on the end, I'm looking for the end. I'm either looking at C's because I haven't got there yet, or I found it, in which case move left instead of moving right and start looking for the beginning. And if I'm looking for the beginning and I see anything other than a $, I just keep moving left. And if I see a $, I'm back to where I started, and I move right and I start looking for an A. So I think this is fine. And this here, if I were to ask you to design a Turing machine to determine if an input string is A to the n, B to the n, C to the n, this is the thing you would give me, this table. Okay, so what was your question? I forgot.
So did I.
You
Oh
asked
no,
what about incorrect number of symbols?
I'm asking is it okay? Well, this it has to be the same number for each character, right?
Yes, that's the only time it will halt. So let's
Okay.
say I had too many B's. I'm going to go into my, so I start out here.
Mm-hmm.
I move right and I start looking for A's. Okay, I found one, mark it out, and then I'll start looking for B's. Don't see one, Move right. Don't see. Oh, there's one. So I mark this out. And I'm going to start looking for C's. There's not one there. Keep going. Keep going. Keep going. Found one. Mark it out. Start looking for the end. Not there yet. Not there yet. Found it. Look for the beginning. Blah, 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 blah. Found it. Okay. Now I start looking for A's. This is fine. Don't need to worry about it. I found one. Mark it out. Now look for the B. Now, as I've just noticed, I do need to add this line here. If I'm looking for a B and I see an X, move right and stay in the same state. I'm going to need one here too. If I see an X, move right and stay where I am. Okay. So now I'm going to look for my first B. That's already marked out. Don't worry about it. There's one. So I'm going to mark it out. And I'm going to look for my first C or my next C. So that's not there. It's not there. It's not there. There it is. Mark it out. All right. Look for the end. I've found it. All right. So I look for the beginning. Anything, 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 $sign. All right. Look for my first A. So the only things I can see are an A, end of the string, or an X. If I see anything else, I don't have a rule for it. So there's an X, that's fine. 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 There's a B. This is not an A. This is not the end of the string, and this is not an X. These are the only rules I have. So since I don't have a rule for this, I don't halt, and I don't have anything to do. You could say hang is a popular word, but essentially the string is now rejected right here. Because I found a configuration that I don't have a rule for. My configuration is I'm in state Q, find A, and my tape symbol is B. And I don't have a rule for that, so I essentially reject the string. I think somebody typed something in chat. Yeah, my drawing is not the best.
But you already have an X though in the place of the last A.
All right, I'll start the string over.
Oh,
it's
God.
fine. This isn't easy. Give me that.
What is this class used for again?
What is this class used for?
Mm-hmm.
This class is used for what can and can't be done.
Okay.
So that's what the class should be called, is what can't be computed. Now, what this particular machine is used for is this is the be all end all. If you can make a machine that shows the current task you're asking me to do can't be done in this machine, then it can't be done in anything else. That's the Church-Alonzo thesis. Is if I can show that, let's say your boss comes to you and say, hey, can you parse input to tell me if it'll be correct or not? If what you should say is, that can't be done. That's a halting problem. And if they go, well, I don't believe you, say, okay, well, you're going to pay me for the next week, and I'm going to make a Turing machine that tries to parse input to see if a given input will halt. And then you take it to them and you say, here's the Turing machine. It will never halt. There you go.
Okay.
So we found the beginning. We're in the QA state, right?
Yeah.
Now find an A. That's the rule. That's the thing we're trying to do. I found an X. So I'm in QA state. Do I have a rule for QA state? My symbol's an X.
Yes, you move right.
Yep, that is what the line says. I found an X. State is QA. I move right, and I stay in the state I'm in. Okay, I found another X. I'm going to do the same thing. I found an X. I'm going to do the same thing. I found the X. I'm going to do the same thing. I found a B. Do I have a rule for being in the QA state and finding a B symbol?
No.
I don't have a rule for it. So what am I going to do?
Then the image just be rejected.
Yep, that's correct. It is rejected.
This is too much. I think I understand it better now.
Good.
But quick question though, when we had all three A's and all three, for each,
Hmm.
how did we know to start looking for A's?
To start or to stop?
Stop looking for A's.
Whenever I find the first A, I stop looking for A's and I start looking for B's.
But when you find like the last A though,
When I find the last A, I better be sure to be finding the last B and the last C at the same time.
okay,
So let's
okay,
assume that this symbol here was the last A. Okay. That means this one would have already been marked out. That means
right.
I'm going to find the next B. This one's marked out. This one's marked out. This is the last B. I mark it out. Okay. I'm going to find the next C. This one's marked out. This one's marked out. Here's one. Mark it out. Find the end. Go to the beginning. I got to find an A. Well, everything's marked out in the tape. So X, move on, move on, move on, move on, move on, move on. I was looking for an A, and all I found was the end of the string. So that means everything was marked out equally. So I should halt.
I think I understand better now. So basically, you're saying that we have to have an equal number of characters in order for the string to be accepted.
Exactly correct.
Okay.
So since you were so kind as to show up,
Uh-huh.
working on it. Oh, come on. This is the general form of what a question would look like on an exam. Let's see. Here you go.
I don't
These
see
two
anything.
questions. Can you see the screen? Oh, you can't. Yeah, I didn't hit the share button. How about now?
Yes.
All right. So this is both ways of the question. This is draw one, and this is tell me what would happen.
Okay. Oh.
So it's really not
Okay.
that much.
Okay. Can I get that PDF? Is that
No,
okay? Okay.
this is
Good.
the one I use to make my exams with.
Okay, so when will we be getting a review for this after the done with the
Well,
Turing
I need to
machine?
look at the actual when finals are. Do you know when finals are?
Yeah. After starting from the 6th of May.
It starts on the 6th.
Yes.
Okay, so that means I need to probably start the review next week.
Yeah. So will this be our last topic? Can
Yeah,
I
I said
leave?
that on like Friday.
Do you say that we have two more topics? You said, I think, and then you say the rest of the class will be the rest of the class. I don't know.
The Church Alonzo thesis is something I want to talk about, but other than that, that's it.
Awesome. And will the question, what was it about? Well, now similar to exam one and question four, would that be on there too as well, right? About the unimplementable function?
Yeah, so that was the homework. I believe it was due today.
Yes.
So if you have a question about it, we can look at it.
Did we have to like submit and say why it's not implementable, or there's some questions and discussions below, but I don't know. So to say yes or no, or I might watch it and everything, but I was kind of confused. What you want us to reply or
So I
whatever.
believe these were the questions.
Mm-hmm.
The point was for you to say it's impossible in all of these because, well, actually that's not true. Here's the solution. Um, the A function is where something's not correct.
Right.
Here is what it should look like. So the A function is the infinite matrix. whose I
Mm-hmm.
comma jth entry for all positive integers is going to be 1 if there is a Python function that maps j to 1. It's going to be 0 otherwise.
Okay.
So here's what that function actually looks like, because here's what the code I gave you looks like. It said, try to evaluate the string I with some j. If you get a runtime error, it's going to be 0. Otherwise, if x is 1, return 0. That is making an assumption right here that we can't make. And that assumption should look like this. Instead of saying just do it, say this. If that input will halt, if that input will actually finish. So I'm going to give my program some input. Once it's done figuring out if the input will work, tell me something. That's impossible. This is the halting problem right here. Given an input, will it halt?
Okay, but we haven't defined halt though in the other function. So when we call in,
Yeah, that's the thing. I want you to implement it. You can't.
oh,
How
so
do I know you can't? Well, if I were to ask you to implement it, here's what I would ask you to give.
right,
Suppose that I
right.
could.
The
That
theorem
would
for
mean that
oh
the
god.
a function can be implemented because that's the only thing missing. And if the a function can be implemented, then so can this. But we already proved that it can't. So by
Right.
theorem
Okay.
3 and these lines here, I know that this function right here is the crux of what can't be done in Python. I cannot have a function that says, given whatever string I'm looking at, tell me if the code will finish. Given an arbitrary input, will the code finish? That's the thing you can't do.
Oh, so Kyle is right. It's impossible in the function as the answer.
This is the impossible part right here. Everything else is fine.
Okay.
Now, the thing I would
So
ask you on an exam is I would delete these lines, and that would be it. I would say prove theorem 4.
okay. Well, thank you.
Yeah, no
I'll
problem.
have to go now.
Yeah, it's fine.
Have a good day.
You too. So I'm going to wrap up the recording. The homework for this was due today. And the answer to these questions is when you get here is when you should run into an issue. Now, it takes a really strong eye to figure this out. So I expected everybody to just have questions about it. It's unfortunate my internet wasn't working. So when you get to A, you should run into this problem, is that it's not doing exactly what we're trying to do. Here's the fix to the problem, is if the input's going to halt before I try to actually use it, then use it. But saying if the input's going to work before I actually use it is something you can't do. This is the halting problem right here. So if you were to get to it in an exam, this would be the kind of stuff I would ask you on. So between the Turing machine example I just ran through and the proofs we have here, that's the topics for today. And I'm going to send this video out with some homework, which is going to be some a little bit of reading and some exercises on Turing machines. So good luck to you all. I'll have office hours tomorrow at noon, assuming Suddenlink doesn't decide to hate me. And I will see you all on Friday.